In this video, the learner will calculate the sum of the interior angles and each interior angle of regular polygons. First, we're going to consider a triangle, square, pentagon, and hexagon. And we want to answer the question, what is the least number of triangles that can be formed using the diagonals of these polygons? So in a triangle, we actually cannot form more triangles using diagonals. A diagonal has to connect one vertex to another, and all of the vertices here are already connected. So here we already have the least number of triangles, which is 1. Okay, here we can draw one diagonal. We could draw another diagonal, but we want the least number of triangles. So the least number of triangles here is 2. In the pentagon, we could draw these diagonals to come up with 1, 2, 3 triangles. And in the hexagon, we could draw these 3 diagonals to draw 4 triangles here. And there are multiple ways that you can draw those 4 triangles into the hexagon. Now let's look back and consider the measures inside each one of those triangles. We know the 3 interior angles of a triangle have to add to 180. So if we have a 3-sided figure, we're going to have one triangle that can be formed for a total of 180 degrees. In this square, we have one set of angles here that will add to 180 and another set of angles that will add to 180. So if we have a 4-sided figure, we have 180 plus 180 for a total of 360 degrees. In the pentagon, we have one triangle here with 3 angles of 180 degrees, another triangle here for a total of 180, and one more triangle with a total of 180. So for a 5-sided figure, a pentagon, we'll have 180 times 3, which gives us 540. For the hexagon, we have 4 of those triangles, so I'll have one set of angles here that add to 180, another here, and one more to make 4. So we have 4 sets of 180. So on a 6-sided figure, we're going to have a total of 720. Now notice the relationship between the number of sides and the number of triangles in each figure. Well, notice the relationship between 6 and 4 is -2. Between 5 and 3, we're subtracting 2. 4 and 2, and 3 and 1. Each time we're taking the number of sides and subtracting 2. And because each one of those triangles has 180 degrees, we're then taking the number of triangles and multiplying that by 180. So 3 minus 2 is 1. 1 times 180 is 180. 4 minus 2 is 2. 2 times 180 is 360. 5 minus 2 is 3. 3 times 180 is 540. 6 minus 2 is 4. 4 times 180 is 720. Well, that gives us the pattern of the number of sides minus 2 times 180 for the sum of the angles inside these polygons. So we have the formula for the sum of the measures of the interior angles of a convex polygon. It's the total number of degrees equal to 180 times n minus 2. n minus 2 is the expression that represents the number of triangles that can be found in each one of those polygons. The value n is the number of sides. I have 2 examples that I want you guys to try. Find the sum of the measures of the interior angles of a regular dodecagon. Find the sum of the measures of the interior angles of a regular 20gon. Next, we're going to find the measure of each interior angle of a regular polygon. Well, if we know the total and we know that the polygon is regular, which means it's equilateral and equiangular, We just have to divide by how many sides there are. So we have a formula for each angle in a regular polygon where we have the sum, which is 180 times n minus 2. Then we're going to divide that total by the number of sides. Remember, n is just the number of sides. So first you're going to find the total and then divide by how many there are. So I have examples that I want you to try. Find the measure of each of the interior angles of a regular dodecagon, and find the measure of each of the interior angles of a regular 20gon. Here we have an example. If the measure of an interior angle of a regular polygon is 108 degrees, what is the number of sides of that polygon? Well, it gives us the measure of an interior angle, which means it's only one of the angles. So we're given the angle measure, we have to work backwards to find out the number of sides. We're going to be using that each formula to do that. I know what that each number is. I know that that is 108 degrees. And I'm going to be solving for n, which is the number of sides. So I'm going to have 108 degrees equal to 180 times n minus 2 divided by n. Now this is just an algebraic equation that I can solve for that value n. So first I need to get n out of the denominator, so I'm going to multiply by n on both sides. Notice on the right hand side that that means those n's are going to cancel away, and I'm just left with 108 times n equals 180 times n minus 2. Now I'm going to distribute that 180 and get 108n equals 180n minus 360. I'm going to add 360 to both sides and subtract 108 and get 72n equals 360. Then divide by 72, so n will be 5. So the number of sides is 5, therefore it's a pentagon that has an interior angle measure of 108 degrees. Next, I have this practice problem I want you guys to try on your own. I'm giving you an interior angle measure of 150, and I want you to find the number of sides. Here we're going to find the missing angle inside this polygon. So first we need to figure out what the entire angle sum will be. So we need to know how many degrees are inside this figure total. So that's step one. We're going to find the total sum. Well, we have to know how many sides there are in order to calculate that. So 1, 2, 3, 4, 5, 6. So this figure is a hexagon. So we know it has 6 sides. So we can find the total by plugging in to 180 times n minus 2. Well, n is 6, minus 2 is 4, so 4 times 180 is 720. So therefore the total sum is 720 degrees. Now that I know the total, I can add all of the expressions together to equal that total. So I'm going to add all of those angle expressions together to equal 720. Combine like terms and I get 600 plus x equals 720. So x is 120 degrees. So that missing angle is 120. Lastly, I want you to try this example. Find the measure of each of the angles of this polygon.